Hi, welcome back, Intro Stats students. So today we're going to start a new unit. It's Unit 12 on significance tests. Um, unit 11 was on confidence interval. So the last unit, confidence interval, and this unit, significance test, those two are really, the those two units are actually what we call inference, where we use it to to estimate the population, true population proportion or true population mean. But in this case, in this unit on significance test, you are given a claim, and we want to see if that claim is it. Is there reason to reject the claim, or is there a reason not to reject the claim? So, and the first lesson we go into is the idea of significance test. And the exercise is um, simple hypothesis testing, right? So, okay, so let's begin. Um, Alex, what? Uh, Alexandra has two brothers, so Hugo and Romain. Every day, Romain draws a name out of a hat, right, to randomly select one of the three brothers to wash the dishes. Alexandre suspected that Romain is cheating, so he kept track of the drawers and found out that out of the last 12 drawers, Romain didn't get picked even once. That sounds really suspicious. So let's test the hypothesis that each brother has an equal chance of one third of one out of three of getting picked in each draw versus the alternative that Romain's probability is lower. Okay, because if everyone has an equal chance of being selected, it has to be one over three, right? One third. But somehow Romain's chance is low because he never gets picked. So, assuming the hypothesis is correct, what is the probability that of Romain not getting picked even once out of 12 times? Round your answers, if necessary, to the nearest tenth of a percent. So, this is an interesting question because the probability that Romain get picked is one third. The probability that Romain doesn't get picked is one minus one third, which is two thirds, right? So every round, if Romain doesn't get picked, this is the probability. The probability of Romain not getting picked is two thirds. And how many rounds do we go? 12 rounds. So it'll be 2 over 3 to the 12 power. Okay? So calculator. 2 divided by 3 to the 12 power. Excuse me. Wow. So it's the probability here, nearest tenth will be 0.0. Wow, will be zero, right? Nearest tenth will be zero because if you take this, this is supposed to be 0.008 to round to the three decimal places, which is the thousandth. But they want us to round to the nearest tenth, which is zero. So it's zero chance, right? 0%. So is zero less than 1%? Yes, it is, right? If so, we have reason to believe that there's foul play. So we will reject, right? If it's less than 1%, if the probability of something not happening, right, is less than 1%, or in this case, we agree that let's agree that if observed outcome has a probability of less than 1%, if something that is so rare to happen, and so in this case, you set it to be 1%, very, very rare, right? To have something that has only 1% chance of happening, it's rare. And if you find something, the outcome less than that 1% chance, well, then you have reason to reject the hypothesis. In this case, our hypothesis is that there's equal opportunity, equal chance for all three brothers, each of them to be selected. So if we reject the hypothesis, okay, we reject the hypothesis, and here we say that it's like 0. Okay, all right. Oh, not quite. We cannot reject the hypothesis. That's incorrect. Why is that? We cannot. Oh, duh. We should reject. What am I saying? We are rejecting. What did I? We should reject the hypothesis. That is correct. And to one decimal place, I believe that's what they want us to do, right? Point zero. Whoa. Okay, get help. Okay. Mm, oh, I see. They want us to change it, which is what we did, though. What we did was correct. You see, 2/3 and raise it to the 12th power, and we got 0.008, which is, they want us to change it to percent and then round to the nearest 10. I see. Okay, so that's what I did wrong. All right, the probability we got is lower than 1%, which was true. All right, we should reject the hypothesis. So when you have when you set it at 1% and you get the probability of less than 1%, you should reject the hypothesis. Okay, so here will be point. Strange, they did not ask to the nearest 10. Oh, 10 of a percent. Okay, so 0.8%, and we say we should reject the hypothesis. Check again, but it's missing a code at the end. Okay, so they're really being stubborn. Well, not stubborn, it's like we forget to put. Okay, all right, let's do another one. So Nails has a magic 8 ball, which is a toy used for fortune telling or seeking advice. To consult the ball, you ask the ball a question, shake it. One of 5 different possible answers then appears at random in the ball. Neil sensed that the ball answers ask again later too frequently. So he used the ball 10 times and got ask again later 6 times. Let's test the hypothesis that each time, each answer has an equal chance of appearing. So it has a 20% chance, which is 1/5, right? Because there are 5 different possible answers, 1/5 chance of appearing in the magic 8 ball versus the alternative that ask again later has a greater probability. The answer below sums up the results of 1,000 simulations. Each simulating 10 random answers with a 20% chance. Okay? So according to the simulation, what is the probability of getting asked again 6 times or more? So there's a simulation that's been done. Okay, so see, like 6 times out of 1,000, that only happened 6. Okay, but we wanted to see what was our alternate hypothesis. Our alternate hypothesis is that it has a higher probability. Okay, it has a higher probability. Um, so that means 6 times. We want to calculate looking at this 6 times or more. So 6 times is 6, right? 6 times or more is 6. 7 times is 1. 8 times is 0. 9 times is 0. 10 times is 0. So if you add 6, 7, we wanted to, like, what's the probability that there are more than 6 times? All right, out of 10, there are more than 6 times that it will reveal that ask again, it will reply as ask again later. So 7 out of how many times? 7 out of 1,000 simulation. Okay, 7 out of 1,000 simulation, which is 0.007, right? And if we round this to percent, change it to 0.7%. So here it should be 0.7%. Okay, so let me put that down as 0.7%.
Attention, any students that are in the field thing, if you're not in a supervised activity with a faculty member,
this is less than 1%. So if it's less than 1%, we should reject the hypothesis.
But if you're not helping out and
so hopefully, if you have any questions, you let me know. Hopefully this helps. Thank you.
Look forward to having you here again tomorrow.